Now we have seen this situation. Now we try to look at the orientation and position of the airplane, because the thing is, this equation is based on body axis. Okay, body axis. Body axis. So this Q is the, for example, this Q here is the pitch rate. Okay, of the aircraft. Okay, the pitch rate of the aircraft based on the body axis. Now, we have also another reference, which is a fixed axis or earth axis. Okay, so ini problem dia, because the thing is, untuk fixed axis dia ada Euler angle atau Euler angle, whatever you call it lah. Okay, so kita ada, for example, we have psi here, your angle, theta, each angle, and phi for roll angle. Okay, so ini yang jadi masalah, because we need to convert. Say kalau convert from Euler angles into the body axis punya rate. Okay, so Euler angle ni nanti kita tengok akan rate jugalah. So dia pun ada rate. So meaning that this psi ni akan ada titik ke atas, ada di atas. Sama juga theta, the rate of pitch angle. Okay, pitch untuk Euler rate will be theta dot, and for roll angle will be phi dot. Okay, so now to do this, dia dalam buku ni dia kata dia akan ambil, dia akan rotate dulu. Okay, so dia akan rotate frame. Okay, remember this ZF. Okay, so this is our original frame. Okay, the original frame. So they rotate the X, Y, and Z frame about Z axis. Okay, to the yaw angle phi. Okay, to the yaw angle phi. So they rotate to the frame to X1, Y1, Z1. Okay, now if you look at the other page, this one. Okay, so this rotate about this axis. Okay, ZF rotate about this axis. Okay, so of course lah, Z1 will be fixed. Okay, sama dengan ZF. But X1 dengan XF dengan X1 will be different. Okay, so dia rotate lah angle psi. This angle psi, they rotate. Okay, so now frame ni dah berubah, the orientation here. Okay, berubah orientation. That's the first one. The second one, we rotate X1, Y1, and Z1 frame about Y1 axis. So this is X1, and this is YF, this is Y1, this one. Okay, so rotate about this at the angle of theta. Okay, then you pitch up. First you yaw, and then you pitch. So you pitch, now X is dah ada dekat sini, mendongak ke atas. So X2 and X3, X2 dah sini. Okay, and while Y1 and Y2 is the same, because it rotates about Y2. Okay, now your Z2 is also changing lah. Okay, at the same angle lah, theta. So this is Z1. Okay, that's the second one. The third one is to rotate about, okay, this X2. Okay, the second frame. Okay, the second frame, about this second frame, rotate about this the angle of phi. So the X3 will maintain, but your Y will change. Okay, from this axis to this axis. Okay, okay, at the angle of phi. Okay, roll angle, and Z also will change. Okay. Now this figure is when you yaw first, then second you pitch, and then you roll. If you change, let's say you pitch first and then yaw and then roll, the result will be different. Okay, or you roll first and then you pitch and then you yaw, the result will also be different. Okay, so care must be taken. Okay, mesti betul-betul take care benda ni because you may make a mistake. Okay, so look at this figure, okay, in the book, okay, later, okay. So then they derive this because they want to find the relationship antara Euler rate dengan rate of rotation of the aircraft. Okay, Euler rate meaning that phi theta psi, and the other rate is PQR. Okay, which represent the whole pitch and yaw rate. Okay, so you study this first. In the end of the day, this is the matrix. So basically, the change of x over t, and this is u v w. Okay, so this one is velocity. Okay, velocity in u v w, and this is the change of x respect to time. Okay, not necessarily u. Okay, uh, and this is from the body frame. Okay, this is velocity component for the body frame. Sorry, this is velocity component for the body frame, and the x over dt is from the absolute velocity. Okay, this is absolute velocity for the y level. Okay, so the x over dt. So this is then c represent cosine. Okay, this means cosine theta and cosine psi, and s represent sine. Sine phi times sine theta times cosine psi, and so on. Okay, so this is a matrix. Okay, so this is from body to oil. Okay, now this relationship can also be done in terms of this. Now, let's say you are the phi, okay, phi dot, which is basically rate of roll, but um, from the from the fixed reference. Okay, this is pitch, the change of pitch angle, and this is the change of yaw angle. Okay, this is from a fixed reference. Okay. Now you want to find what's pitch rate, oh sorry, roll rate, pitch rate, and yaw rate on the body axis, and this is a conversion. Okay, so notation is the same as for sine and C for cosine. Okay, and if you kebalikkan, okay, you reverse, okay, invert, or reverse whatever you call it, dapat macam ni pula. Okay, um, you may not need to derive this lah. If you want to derive, yes, please at your own time, please do it. Okay, alright. Later kalau ada question, tanya saya kemudian. Okay, sebab sekarang I nak proceed to gravitational and thrust force. This is just a conversion antara dua axis of reference axis. Okay, because one is and one axis is moving with the body, with the airplane. Another one is fixed. Okay, it's just fixed. Okay, for 3.4, we are looking at the gravitational and thrust forces. Okay, because you have to remember the airplane is flying, there is gravity. Now, gravity ni dia letak mana? Okay, because previously we have derived aerodynamics. Okay, itu pun belum habis lagi. Belum habis lagi, kita baru derive the equation of motion. Okay, kita baru pecahkan to that 6 equation, and then lepas tu kita buat conversion antara dua axis. Now we want to put gravitational and thrust force. Okay, because these two forces they are not part of aerodynamics. Okay. One is that when you pitch, okay, there will be change in gravitation weight direction. Okay, if your pitch angle is 0 and the airplane is just level like that, like this, your weight is 100% in ZB, or body, okay, Z axis. Okay, body Z axis. But when you pitch up, okay, so the weight component of weight, or mg, some of the components will be in ZB and some of it will be in XB. Okay, will be in XB axis. Okay, although one is positive, the other one will be negative lah. Okay, And not to mention that if you roll, okay, now if you roll, uh, if it's level, then 100% goes to ZB. But if you start rolling, okay, then you have roll angle, so some of the weak component will go to the YB axis, okay, YB axis. Okay, and if you combine this, okay, so this is mg, and then you pitch, okay, pitch, so the zb component will become mg cosine theta, okay, and then the zb mg cosine theta, kemudian ni, okay, uh, there will be mg cosine theta sine phi in y direction, yb direction, and in zb direction, uh, still the same lah, okay, still the same, you see. Ah, 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 ah. Yes, you're right. Okay, this one is mg cosine theta. So the, the zb component, okay, um, yeah, duduklah dia diam. Nanti you tahu. Okay, alright. I pun kena gula sikit. Dah petang ni, dah makan ni kan, tapi gula juga. Okay, sorry. Okay, but itulah kalau ada blackboard ni juga penting. Tapi tak apalah. Don't worry, you can derive this. Okay. Alright, and then for figure 3.5, this is a contribution of the truss. Now, not all aircraft you have truss in line with the center of gravity. Okay, there are some differences like this one. The truss is slightly below the CG. Okay, the truss line is slightly below the CG. So there is the moment, the pitch moment there. Okay, because truss T times ZT, which is the distance, the vertical distance between the CG and the truss line, will give you pitch up movement. Okay, that's one thing. That is if you pitch up, and if you have two engines, for example, like this, and if there is a differential difference between the right and the left engine, okay, it will produce a yawing moment. Okay, if there is a difference. Okay. So like this, yeah, your moment due to trust. So how do we read this? This pitch moment due to trust. Okay, and this is your moment due to trust. Okay, so the force component. Okay, so from this figure 3.4, we can derive this equation. So Fx, okay, the gravity, the force in x due to gravity is minus mg sin theta. Okay, and in y direction due to gravity is mg cos theta sine phi, and fz due to gravity is mg cos theta cosine phi. Okay, that confirm that this is mg cosine phi. Okay, not this one, but this one. Okay, so this is mg cosine phi, and this zb will be mg cosine phi cosine theta cosine phi, and this one is mg cosine theta. Apa ni? Banyak sangat angle, but you get what I mean lah. Okay, alright, so propulsive force, okay, Fx propulsive, kita just simplify simply as xt je. Okay, xt, force in y direction due to propulsion or engine, simply yt, and z is simply zt, and the moment, okay, is lt, okay, rolling moment due to thrust. Okay, pitch moment is mt, okay, pitch moment due to thrust, and n, okay, this is also due to thrust. Okay, so your moment due to thrust. So I hope you get it. Okay, so dalam 15 minit ni, I think I give you a break.